Hey, it's Joe Frere with Geek Toolkit, and today I'm going to talk about a project I call DynaFrame. DynaFrame is short for Dynamic Frame, and I've got one on either side of me here. I've got two running right now, and they're basically a Raspberry Pi connected to a monitor. The thing that they do is they solve a problem for me that I was having after collecting a lot of artwork from Comic-Con for years. I'll give you an example of a piece that I got from Comic-Con. This is from Evangelion. And this is the size of a lot of the artwork I was buying. The frame for this was about $15 to $20 alone. And it got kind of hard to match the frames up after a while. If you do it year over year, some of the frames go out of style or you can't find that frame anymore. Besides the cost of the frame, this is an anime piece. I have a lot of video game pieces. Here's another one I haven't gotten framed yet. This is an Alice in Wonderland. This is a Disney piece. The artwork starts clashing. This style is very different than what I have here. Between the cost of the frames, the clashing styles, and just running out of room with all the artwork I had in my house, I had to come up with a solution that was clean and fairly inexpensive. So I set a couple of parameters that I'll go into in a second, and I created this project here. And I've been using it for the last couple months, and I really enjoy using it. I wasn't sure if a monitor could replace a piece of artwork on the screen, but it has for me. And one of the things about that is I can have the artwork I want when I want it in the room, and I can do some things that are even beyond static artwork. For instance, there's things called plotographs and cinemagraphs, and what these are in short is animated images. A plotograph, you actually start with an image and animate it. A cinemagraph, you start with a video and you freeze most of it, but you leave some of it animated. That may not make sense, so let me show an example. On this frame here, I'm going to load up an Evil Ryu that Nopes did. And what I did is I took that and I brought it into an app called Warble. I'll do another video that talks about this part, but you can see that the eyes are glowing, the fireball is actually fire animated, and there's a bit of an effect behind him. That is an example of a plotograph where I took an image and animated it. This makes for this really cool effect where I've got these posters that are almost living on my walls. Now I talked about the problem of clashing artwork. And the way this solves this is because I can sync my art to either a web browser or what's called MQTT, which I'll talk about later, which ties into home automation, I can make these do whatever I want. For instance, if I'm using this room as a makerspace, I might want to have patent artwork up on the wall. And if I want to sync both of them, no problem. I can just go click patents on both and have both of them showing patent artwork. If I'm going to start doing video games, I can go here and switch them both over to video game artwork. This is Nopes artwork on both frames. And I can have animated artwork, and in the future, I feel like I'll be able to expand this project quite a bit. The next thing I want to do is talk about the constraints in the design, because part of my passion around Geek Toolkit is kind of teaching my process of how I engineer some things. Here's what I came up with for my design constraints. I wanted it to be about $150 per frame. I felt based on what I was paying for Comic-Con frames, this was a reasonable price to go for. I also knew that I was going to have to buy monitors and some kind of compute system, so it was going to be a little bit up there. I wanted to be able to easily add media. I didn't want to have to pull the micro SD card out or plug in a USB drive. I wanted to be able to do it remotely if possible. I needed to support images and videos because of what I talked about before with the cinemagraphs and the plotographs. And I didn't want it to take up a bunch of power because I knew they might be on for several hours. Controlling via a phone would be a nice to have, or some kind of interactive home automation control. And also, if I ended up hating the project, I wanted to be able to go back to a monitor. Here's what I ended up with on the final implementation. I used a Raspberry Pi 3B Plus, which is $35. If you were to go to a A+, I think you'd have a better Raspberry Pi that's more appropriate for this. It would cut $10 off the price. That LG is the monitor model I used. It's an IPS monitor that had really good visibility, viewing angles, and it was a 22-inch monitor, which was the same height as the frames I was using from Comic-Con. And then the stuff that I see a lot of people leave out that I think is really important, little things like HDMI cables, micro SD card and such, added another $20. So I went just a little bit over budget. Not too bad though. I came up with a couple different ways to add media that I think is really nice. One is just using network shares, drag and drop files, and off you go. The other way is to use OneDrive, Dropbox, or some kind of cloud sharing. This one's a little bit hacky. You have to have a computer that actually runs the sharing script for you. But with this, you can add something, let's say from a phone to OneDrive. The computer will sync it over to the frame, and then it'll end up on the frame. For control, each frame has its own web server, so it has independent control. And also I implemented MQTT, which I'll talk about later. This allows home automation systems to interact with the frames and do some really cool effects. If you want to build this yourself, it's very simple. Attach a Raspberry Pi to the back of the frame. I did mine non-destructively, that way I could convert it back to a monitor. Flip it over and remove the base, and then you're going to want to create an image based on the description links I have below. You'll want to take that image and put it onto a micro SD card. If you're on Windows, Win32 Disk Imager or Etcher will work. On a Mac, you can also use Etcher. Once that SD card is imaged, plug it in and boot it, and the next portion of this video will walk you through the rest of the setup. For completeness, I've included all the steps we're about to go through on the left-hand side, in case you'd rather follow them this way. Now we're going to go into the actual setup of the Raspberry Pi after it's booted, and I'll show you the walkthrough from there. When you boot up, you'll probably see a blank screen. Move your mouse to the top, click on Terminal here to get a terminal window. The command you'll want to execute is sudo raspi-config. This is short for Raspberry Pi Configuration Tool. So raspi-config. You'll end up here. Want to change a couple things right off the bat. Go into change user password, enter a new password. Make sure that they match. Go down to network options, change the host name from left display to something that means something to you. Mine's called left display because it's the left one in my makerspace, so that way I know which one I'm working on. You want a unique name for each display that you set up. Go back down the network options and go to Wi-Fi. Enter your Wi-Fi access point and password. This will allow the Dynaframe to connect to your wireless network, which will allow you to remotely manage it, including adding artwork or editing the scripts. Once that's all done, go to finish, and you'll probably be asked to reboot. Go ahead and reboot, and upon booting, it should connect to your Wi-Fi network. To confirm that, if you do an ifconfig, look at WLAN 0, which is short for wireless LAN, and 0 is the first one. You'll see iNet, and then look for an IP address there. Keep that IP address in mind. That's how you'll remotely manage this device. If you have an IP address there that's not like a 168, you should be good. There's one thing I forgot to do when creating this image, and that is to install a library called Paho MQTT. To install it, you'll want to do sudo pip3 install Paho-MQTT. Okay, if you go to / the IP address of the Raspberry Pi, you'll see a frame folder. If you go into that frame folder, this is where everything goes. The show.py is actually the Python script that will look at the code later. And if you want to edit it, this is where you'll want to edit it. So what I'm going to do is go grab some artwork. I'm going to grab some from Dash Martin, Giovanni Francisco Luengo, and Nopes. These are all from DeviantArt. And I'll paste those here, and we're going to fast forward to get through this part. Okay, so you see all I've done here is pasted folders, and inside of the folders are 3 different types of files that we can put in here. We can put JPEGs if you want to put images, MP4s if you want to do videos, or MOVs if you want to do videos. I'll work on expanding this as I work on the code, but for now this is what I'm limited to. These folder names are each, you can almost imagine them like a playlist. So you can have another folder and have duplicates of these pictures in that folder. That works out just fine. That's it. Now the content is on the frame and it's ready to be displayed. The next thing we're going to do is show how to control this from a phone. At this point, once you've copied the content over initially, you may want to restart one more time, and the frame should come up with the artwork automatically to start. The next thing we'll do is go to the browser, and we're going to navigate to this IP address. I want to very quickly go over how to control the frames via the web browser. You can do this via a browser on a tablet, on your desktop, or on a phone. Navigate to the IP address of your frame, :8000. Each frame has its own web server, so each frame gets controlled separately when you're doing it this way. What you'll get is a list like this, and each of these is a playlist. If you look over here, you'll see that these match the folders that are actually on the device. And if I double click on like Dash Martin, these are the pictures that are in his folder. What this means is when I click Dash Martin here, it's almost like picking his playlist, and this is what will show up on the frame. If I click on Giovanni's, I've switched playlists. The current playlist is specified down here so that you know what's on the frame, and you can always go to the IP address to see what's currently playing. This is customizable via the Python code, and I'll show you where to do that. Let's take a look at the Python code actually. I'm not going to do a deep dive on the code, but I do want to show the code for those that are interested in learning and for those that want to edit it so that you know where to edit it. The first thing that you would want to edit is if you're going to tie this into your home automation system, you want to change these to your MQTT settings. If you've set up a home automation system, you're probably familiar with what that is. If not, I'll try to explain it in the next section. When you're showing an image, they show for 30 seconds. This refresh interval equals 30 is where that's set. If you want them to set for a minute or longer, just put the number of seconds that you'd like them to show for. The web page that I just showed on the phone and in the browser, this is the HTML and the CSS for that page. So if you want to change colors or what it looks like, this is where you would go. This first method here is the HTTP handler. Every time you navigate to the page, this fires. getRandomFolder fires at the start. This is so that when you start up the frame, you don't get the same playlist each time. The MQTT subscribe code is here. When an MQTT message is sent from a, for instance, home automation system, this is the code that fires. The top here is just debug code, and then we set this global image path. Image path is the folder that we're currently set on. Basically, we take the message payload that is sent via MQTT for what we've subscribed to, decode it, and set it to image path. We then kill any video players that are going, and then we set the image path to be the new image. The rest of the code will take care of killing the image player if it's currently showing an image, and it will start on the next, basically the next image will be from this new image path. This is how things like the home automation setup work. If you were to start Netflix on a device, and then you would want to send an MQTT message to the frames to say, hey, now I want to show movie posters, that's what the code looks like for that. I sleep for 10 seconds at the beginning of this script, basically to let the networking start up and give it a chance to get an IP address. Sometimes Wi-Fi can be a bit slow. We immediately get the current IP address of the frame, and then I log it out so that you know what IP address is currently being used by the frame. This is good for debugging. If for some reason you lose connection with the frame, you can go and find the log and see what IP address is there. This is the main loop for the frame of what's going on. It's going to go through and find every file in the directory that image path is set to. So if it's set to, let's say, movies, then it'll go and get all of the images. We'll then kill any currently playing video or image player. Doesn't matter if we find them or not, we just kill them every time. The reason being is if for some reason these start leaking, then it'll take the entire frame down. So it's just kind of a clean way to start out fresh and know that there's nothing on the frame. Please keep in mind, I learned Python when I was doing this, so I may be doing things in a horrible, horrible way. I can tell you that they work, but they're probably wrong. If you're learning Python, this might be good to learn some techniques, but it's probably not good to learn the way to do things. That being said, this is how this works. I take the end of the file, I uppercase it, and I do a comparison, basically a string compare. If it's an MOV or an MP4 file, then I launch OMX Player, basically by using a shell execute. If it's a JPEG or an image file, then I wait a second, and then I run this command line. This display equals :0.0 is for multiple windows. I think there are multiple X windows. This is something I'm not fully clear on, but I know that if I VNC into the machine, I end up with a separate X window. And what would happen is the frame would not get the image shown on it when using the FEH tool. -X, I believe, was for full screen, and the ampersand was to prevent the process from taking over the console and kind of hanging. So it'll keep going after that ampersand. We'll look at the current refresh interval, and we'll set a counter. When the counter is bigger than the refresh interval, then we break out of this while loop here. We kill the current things as we come back around, pick the next image, and we start all over again. I know that code walkthroughs are never fun or probably exciting, but I think they are useful for both learning and if somebody wants to modify the code. I just wanted to give a quick walkthrough. It's very simple. This one file is all there is. There's a launcher for shell executing on startup, but it's one line that basically says run Python 3 and call this. Okay, so the next thing we will do is, I believe I'll show the video demos of the Netflix demo and a little bit of the more of the frames. I'd like to talk about some of the artwork I've gotten on there, and then I'll do final thoughts. This is a demo of the MQTT home automation functionality. Now that sounded really boring, but here's what's cool. Right now I have pattern artwork on the frames. And what I'm going to do is switch over to my television, which is playing YouTube. And I'm going to hit the Netflix button. This sends a message to my home automation system and tells the broker, hey, there's a video playing. The frames are subscribed to the broker, and so they both switch over to movie posters. This was my dream the whole time. I wanted to be able to, when watching movies, have the frames dynamically switch to movie posters because that was the task I was doing at the time. Eventually I'll get it working for video games and stuff like that. Now the other thing is, when I switch away from movie mode, in this case if I switch back to watching YouTube, I want the Dynaframes to go to artwork. In this case I'm going to switch one to Nopies and one to Dash Martins from DeviantArt that I've been using for this entire video. You can see they actually switch back faster than they switch to the movie posters. What you just saw was the demonstration of MQTT. MQTT stands for MQ Telemetry Transport. It used to stand for Message Queue Telemetry Transport, but there's not really a queue. Think about subscribing to a magazine. When you subscribe to a magazine, there's a topic that you're interested in, and you're the subscriber. You tell something, in this case let's call it the broker. We tell the broker, hey broker, I'm interested in cars and Arduinos. Or somebody else might be interested in cosplay and chinchillas, but also cars. The broker registers who the person is and what they're interested in, what topics they're interested in, and it keeps that. The subscribers have told the broker what they're interested in, and here come the publishers on the other side. Think of these as the magazine authors. Arduino Magazine doesn't talk directly to any of its subscribers in this case. It just tells the broker, hey, I've got some information. And it hands that information to the broker and it says, this is on the topic of Arduino. The broker will hand that to the subscriber and say, hey, here's information that you subscribe to. Chinchilla Magazine will tell the broker, I've got some info, and the broker will be smart enough to only tell the second person. Car Magazine will tell the broker, I have info as well, and the broker will be smart enough to tell both people because they both were subscribed to the car topic. So these are the words you're going to hear a lot: subscriber, publisher, topic, and broker. Hopefully this chart here explains what those are. Now, how does that make the demo that we just saw work? Well, replace the same chart, replace the subscribers with the frames. The frames tell the broker what they're interested in. What data do they care about? In this case, the top frame is going to say, I want to know what movie, if they're watching a movie or if they're playing a video game. And the bottom frame is only going to be interested in if they watch a movie. I contrived this example just to show that not everything has to subscribe to all the topics. On the right, we have our publishers, or what they would look like in a home automation scenario. Now, Xbox Live itself is never going to publish something MQTT to the broker directly. But what will happen, and this is why I talk about this as a home automation bridge, there's a home automation setup that will monitor Xbox Live and say, hey, is this person logged in? And if so, it can be programmed to tell the broker, this person's logged in. Tell any of your subscribers that care about it that this happened. Same with movie playing. It's not like my TV that played Netflix subscribed to MQTT, but it is a Roku-based TV. It's called a TCL brand. And my home automation system knows how to talk to the Roku and monitor it. And when it started launching Netflix, the home automation system immediately tells the broker, hey, a movie's playing. Now, since both of those frames were listening for a movie, they both got the message that a movie is playing, and then they picked the playlist of movies. Alexa, turn off Makerspace.
Okay.
Alexa, turn on Makerspace.
Okay.
That was a demo of my final feature, which is to use a Z-Wave device to control the frames turning on and off. I also have the frames synced with the room's lights, so when I turn the lights off, the frames turn off. The frames would cost about $12 a year to run at 8 kilowatts an hour per frame. With this feature, it brings it down to about, I estimate, $5 for my usage. This is for both the Raspberry Pi and the monitors. The total draw that I'm seeing is about 18 watts. This video went a bit longer than I intended, but hopefully the information in it, the MQTT breakdown, and some of the Linux stuff helped out. I spent a lot of time making the image and getting it uploaded. The other option was to explain the 10 or 15 steps I would have had to do to make the image, and I didn't know if that was going to be useful. Please give me feedback in the comments below and let me know if this is the kind of video that you'd like to see, and if this is helpful and if you learned something. If I went too fast or if I'm not explaining the technology well, feel free to let me know and I'll try to get better at that. Really still filling out this whole YouTube thing and trying to figure out what my channel will look like. But so far you guys have been really supportive and I really appreciate it. So thanks a lot. Thanks to the DeviantArt artists, and till next time.